Time, we are now awaiting the unfurl of the two Ultraflex solar arrays on the back of the Cygnus cargo vehicle. The vehicle lifted off this morning, 3:46 p.m. Central Time, right on time, making a 9-minute ascent into orbit with 7,600 pounds of cargo on board.
Attitude is nominal. Core pressurization looks good.
The Antares lifted off from the Wallops Flight Facility at Pad 0A at the Mid-Atlantic Regional Spaceport.
Stable operation, full power, both engines.
The main engine fired for 3 minutes 35 seconds before the first stage separation and after main engine cutoff. The second stage lit for 2 minutes 30 seconds. And after a 2-minute coast period, the payload, the Cygnus itself, separated from the second stage and was inserted into an orbit.
5% power. Attitude remains nominal.
After a series of successful burns following the launch of Cygnus earlier this afternoon, Cygnus is poised for unfurling those solar arrays. Watching over the deployment of the solar arrays are flight controllers over at Northrop Grumman's Mission Control Center in Dulles, Virginia. They have conducted a go, no-go poll for unfurling those solar arrays, everything looking good, and on track for an on-time solar array deploy here in the next just about 10 minutes. Solar array deployment takes about 30 to 35 minutes for both the Ultraflex solar arrays to unfurl. Once the command is given for deployment, it takes about 10 to 15 minutes for the solar arrays themselves to actually start deploying. The process itself then takes 20 minutes to complete. You'll hear first that the Wing 1 is out and Wing 2. They'll go one at a time. And then they'll check to make sure that both solar arrays are drawing power. And that'll take it throughout the rest of its day-and-a-half long journey to the International Space Station. The flight controllers that you're seeing here at the Dulles, at the Northrop Grumman Mission Control Center in Dulles, Virginia, undergoing a series of steps before they send that command for unfurling the solar arrays. Again, that process takes about 30 to 35 minutes once initiated. The Cygnus vehicle on its CRS-11 mission is named after Roger Chaffee, the vehicle itself being called SS Roger Chaffee. Chaffee was born on February 15, 1935 in Grand Rapids, Michigan. He got his private pilot's license through the Naval Reserve Officers Training Corps before graduating from Purdue in 1957 with a bachelor's in aeronautical engineering. After graduation, he flew for the Navy and accumulated over 1,800 flight hours before his selection as an astronaut in 1963. He began his training as an astronaut in 1964, served as Capcom and Mission Control during the Gemini program, and received his mission assignment on the first flight of Apollo in January 1966. On January 27, 1967, Chaffee, along with Virgil Gus Grissom and Ed White, perished in a fire that ignited during a plugs-out test of the Apollo Command Module out at the Kennedy Space Center. Chaffee's sacrifice began redesigns of the Apollo vehicles that ultimately landed Neil Armstrong and Buzz Aldrin on the moon nearly 50 years ago on July 20th, 1969. We're now 50 years past some of the missions of the Apollo program. Nearly a month from this date is the launch of Apollo 10, 50 years ago. Apollo 11 was the mission that took Neil Armstrong and Buzz Aldrin to the surface of the moon. Again, the Northrop Grumman flight controllers conducted a go, no-go poll. Everything's looking good to deploy those Ultraflex solar arrays and start gathering power for the day-and-a-half long journey to the International Space Station. Space station itself currently tracking 257 statute miles over the middle of the Indian Ocean. You can see the Cygnus vehicle trailing shortly behind. Again, that rendezvous will take just about a day and a half. The Cygnus vehicle will make its way incrementally closer and closer to the International Space Station, to a capture point just about 10 or so meters away from the International Space Station. NASA's Anne McClain will use the station's robotic arm, backed up by David Saint-Jacques of the Canadian Space Agency, to reach out and grab the vehicle. They'll both be ready again Friday morning for that capture time, scheduled around 4:30 a.m. Central Time. And McClain at David Saint-Jacques will be leading the grapple operations. They are joined by the crew of Expedition 59, which includes Roscosmos cosmonaut Oleg Kononenko, the commander of Expedition 59, as well as Christina Cook and Nick Hague of NASA, and Alexei Ovchinin of a Roscosmos cosmonaut. Crew of Expedition 59 now in a crew sleep period. It's the end of their day for operating on Greenwich Mean Time. We're just a few minutes away from the scheduled deployment of those solar arrays. Again, they will gather power through the Cygnus's journey around the Earth a few laps before rendezvousing with the station a day and a half from now on early Friday, April 19th. The vehicle itself is carrying about 7,600 pounds of cargo. This includes scientific experiments, spacewalking equipment, crew supplies, vehicle hardware, and of course some external hardware, including some CubeSat deployment equipment to deploy a series of satellites, including satellites called ThinSats, in a mission that will come after its conclusion with the International Space Station. That's scheduled to be in July. Cygnus will carry several tons of trash away from the space station, and that equipment will deploy those ThinSats and CubeSats during an extended mission past the time it will be docked to the International Space Station. You're looking at the Northrop Grumman flight control team over in Dulles, Virginia. After a successful launch, Mission Director Ken Peake took the team through the launch procedure. Now taking over is Paul Brower, Mission Director for Solar Array Deployment, Rendezvous, and Capture. Standing by and monitoring the progress of Northrop Grumman, making sure the International Space Station, which is the ultimate destination of the Cygnus vehicle that launched earlier this afternoon. Monitoring those systems are the teams here in Mission Control Houston. You're looking at the Orbit 3 team here at Mission Control Houston, the last shift of the day. Leading the last shift of the day is Flight Director Greg Whitney, overseeing the progress of Cygnus, making sure it's still on track and on its way to the International Space Station. Very few flight controllers, as you can see, for the night shift. One of the key flight controllers here in the room, currently on a break, is Visiting Vehicle Officer Ray Bigenes. He'll be communicating with those flight controllers in Dulles, Virginia, making sure everything's on track as Northrop Grumman flight controllers take the Cygnus through its day-and-a-half journey in space to the International Space Station. Getting some views from the International Space Station as it flies 255 statute miles, crossing over into an orbital daytime just over Indonesia. Trailing behind is the Cygnus cargo vehicle, currently over the middle of the Indian Ocean. At this time, we're tracking about 10 minutes, less than 10 minutes at this point, away from the initiation of the solar array deploy. Once the solar arrays actually start deploying, that process takes just about 20 minutes to complete. We'll get confirmation. Again, there's two Ultraflex solar arrays. We'll get confirmation of each as they completely unfurl, Wing 1 and Wing 2. Once they're successfully drawing power, we'll confirm that next few milestones, which include a series of burns to get incrementally closer to the International Space Station over the next day and a half. Again, Cygnus is loaded with 7,600 pounds of cargo. Just about half of that, maybe a little less, is scientific experiments, and there's plenty on board. There's one experiment called Astro-B, and this is NASA's next generation of free-flying robots aboard the space station. They are self-contained, cube-shaped robots and are designed to help scientists and engineers develop and test technologies for use in microgravity to assist astronauts with routine chores and give ground controllers additional eyes and ears on the space station. These autonomous robots, powered by fans and vision-based navigation, perform crew monitoring, sampling, logistics management, and accommodate up to 3 investigations. They're operated remotely on the ground. Another experiment is manufacturing fiber optic cable in microgravity, the experiment itself called Space Fibers. This experiment will evaluate a method for producing fiber optic cable from a blend of zirconium, barium, lithium, sodium, and aluminum. It's called Z-Bland, and test that material in space. Z-Bland produces glass 100 times more transparent than silica-based glass, exceptional for fiber optics. Microgravity suppresses 2 mechanisms that commonly degrade fiber, and previous studies showed improved properties in fiber drawn in microgravity compared to that fabricated on the ground. Z-Bland fiber is a unique candidate for improving imaging, remote sensing, and next-generation optical communications on Earth due to its low loss and higher bandwidth. There are also plenty of biological experiments too, including the bioanalyzer. This is a Canadian Space Agency experiment that will be an onboard instrument that serves as a platform for scientific experiments where astronauts can easily test different body fluids such as blood, saliva, and urine and get returned key biomedical analyses within a few hours. Scientists will be able to use the bioanalyzer's data to accelerate science experiments. In the future, this type of device could help keep a closer eye on astronauts' health. Astronauts show accelerated arterial stiffening, thicker artery walls, and signs associated with the development of insulin resistance after spending 6 months in space. This dramatic change in the carotid artery aging was unrecognized until recently, so the vascular aging investigation will include critical onboard investigations to test the relationship among a crew member's metabolism, aging arteries, and aging bones. The results of this study could have great importance for assessing a newly identified risk for astronaut cardiovascular health, potentially pointing to mechanisms to reduce risk. And that's just a few of the experiments among the 7,600 pounds of cargo currently aboard the Cygnus cargo craft crossing the Terminator line and following the trail of the International Space Station as it crossed Indonesia just recently. Space station itself flying just south of Taiwan at this time. Now, the initiation of solar ray deployment has begun, but once that command is given, it takes just about 10 to 15 minutes for the solar rays themselves to actually start deploying. And we're waiting for that confirmation at this time. You can see on the image of the Cygnus cargo craft on this map as it orbits the Earth. The solar rays we're looking at are the two ultraflex solar rays at the sort of back, at the left end of the image that you see of the Cygnus cargo craft. Watching over the systems of Cygnus as it orbits the Earth are flight controllers of Northrop Grumman out at the Mission Control Center in Dulles, Virginia. Once Cygnus arrives to the International Space Station and is captured by Anne McClain and David Saint-Jacques at the hands of the controls of the robotic arm, robotics operators on the ground will maneuver the station's robotic arm to its berthing position, where Cygnus will spend the next 3 months. That berthing position being sort of the middle of the International Space Station, the Unity module, Node 1, on the nadir side, that's the Earth-facing side. This, of course, is the International Space Station Flight Control Room in Mission Control Houston, looking after the systems aboard the International Space Station. Flight Director Greg Whitney leading the teams here for Orbit 3, the last shift of the day. That'll be carried throughout the rest of the day through midnight. Teams here are watching over the International Space Station, but also the progress of the Cygnus cargo craft, making sure that it hits all its milestones on its journey to rendezvous with the International Space Station, scheduled for early Friday morning. Everything looking on track so far to deploy those solar rays. Again, the command has already been sent, but it takes about 10 minutes for the solar arrays themselves to start deploying. We should be seeing that in just about 40 seconds. Now, in a short loss of communications, loss of signal with the Cygnus cargo craft. The first milestones, though, of the Cygnus deployment have been initiated. Standing by once we come back from that loss of signal for those next series of milestones, again, looking for the solar array deployment. You're looking at a view from the International Space Station as it passes just east of the coast of Japan over the North Pacific Ocean, 250 statute miles over the Earth. Trailing shortly behind is the Cygnus cargo vehicle. Flight controllers over at Northrop Grumman flight controllers at Dulles, Virginia, verifying the steps incrementally of the deployment of those solar arrays. You're looking at the International Space Station on the right, a view from the International Space Station on the right as it orbits 258 statute miles over the North Pacific Ocean, Cygnus trailing not too far behind. On the left at the top, the Dulles Northrop Grumman Mission Control Center at Dulles, Virginia, watching over the Cygnus cargo vehicle. And at the bottom left, International Space Station Flight Control Room, looking after the systems of the International Space Station and monitoring Cygnus during its solar array deployment activity, currently progressing. Cygnus again trailing not too far behind, now passing over Japan as the International Space Station flies over the North Pacific Ocean. Once again, a view from the International Space Station looking down at the North Pacific Ocean as it approaches the west coast of the United States. Cygnus cargo vehicle trailing not too far behind over the North Pacific Ocean on its day-and-a-half long journey to the space station. We're now in the middle of the deployment of the solar arrays. The photos of which you can see in this image. We're now 2 hours 52 minutes into the mission duration of Cygnus since launch at 3:46 p.m. Central Time this afternoon. At this time, Dulles flight controllers, or Northrop Grumman flight controllers in Dulles, are monitoring the Cygnus cargo craft as it deploys the solar arrays and starts beginning to collect power from those solar arrays. We're in the final steps of this deployment. This is one of the major milestones of Cygnus during its journey to the International Space Station. The International Space Station, currently 256 statute miles right over the northern coast of California. Trailing behind is the Cygnus cargo vehicle, just 2 hours and 56 after its launch from the Wallops Flight Facility, Pad 0A at the Mid-Atlantic Regional Spaceport over in Virginia. At this point, making nearly 2 laps around the Earth, chasing down the International Space Station on a day-and-a-half long journey. Right now, the vehicle is in the middle of the deployment of its 2 solar arrays. In the picture here, you can see on the left, those solar arrays will provide power for Cygnus during the rest of its journey until it's captured by the robotic arm of the space station tomorrow, or Friday, April 19th at 4:30 a.m. Central. Northrop Grumman flight controllers over in Dulles, Virginia, monitoring the telemetry of Cygnus and going through the milestones to complete the deployment of those solar arrays and make sure they're gathering power. International Space Station flight control room on the bottom left. The flight control teams there are part of Orbit 3, the third shift of the day. This room is staffed 24 hours a day, 7 days a week, looking after the systems of the International Space Station, which you see in the center of the map there. Flight controllers there are tied closely to the progress of the Cygnus, chasing down the International Space Station, currently in the middle of deploying the solar arrays. International Space Station, 255 statute miles over the southern border of the United States, passing over, about to cross right over Mexico, and just into passing over the western border of Peru after that, into an orbital nighttime. At this time, the 2 Ultraflex solar arrays have completed their deployment, and Northrop Grumman mission controllers flight controllers have confirmed that both solar arrays are drawing power. This is a critical milestone in Cygnus's journey to the International Space Station. Now that both solar arrays are deployed and collecting power, Over the next day and a half, the flight control teams over in Dulles, Virginia will continue to watch over Cygnus as it conducts a series of burns to get incrementally closer to the International Space Station. Everything is on track for an on-time rendezvous to the space station on Friday morning, currently looking at a capture time of 4:30 a.m. Central Time. You can join us for our live coverage beginning at 3 a.m. Central. Again, that time for capture 4:30 a.m. Central. Robotics operators on the ground will take over control of the station's robotic arm. In the image you can see on the right of Cygnus capturing a former Cygnus vehicle. It'll take some time, and we'll come back on at 8 a.m. Central for our coverage of the installation. Robotics flight controllers will maneuver the Cygnus to its berthing position on the nadir side of the Unity module. This is the Earth-facing side of one of the nodes at the center of the habitable volume of the International Space Station. But for now, that critical milestone of solar array deployment is complete after a successful launch more than 3 hours after the launch of the Cygnus cargo vehicle from the Wallops Flight Facility. Join us again for that capture coverage coming up early Friday morning. Until then, this is Mission Control Houston.